Hello, this is Dr. Raz. In this video, I would like to show you another continuous probability distribution, which is probably the most common, is normal distribution. And normal distribution is very good distribution for heights and weights of people, test scores, scientific measures, uncertain quantities such as demand for products, rate of return on stocks and bonds, time it takes to complete an activity. So it's very, very common distribution. So normal distribution has two parameters: one, standard deviation; two, mean or average. So average is telling me the location of the distribution. So if the mean is higher, this whole bell curve will go this way. If mean lower for a given data set, the whole curve will go to the left. And standard deviation tells me the shape of this distribution. So the higher the standard deviation is, the more flat curve you will see. The lower the standard deviation is, the more vertical distribution you will see. So those are two parameters in normal distribution. So you can see the density function of normal distribution is pretty ugly function. And again, if I excuse me, if I put any x here, the result will go to 0. The reason is that, again, it's a continuous distribution. That's why instead of using probability density functions, we use probability mass functions. All right, so you can see pi here and so on. So let me just show you a couple examples. So if the different means, as we talked before, so this mean -10, this mean is 0, this mean is 20. As you see, the same curve, however, it's just the location change. That's why mean is called also location parameter for normal distribution. And if I have less standard deviation, as I talk about, the distribution becomes more spiky. All right, so why normal distribution is pretty cool? Because knowing the effect of mean and standard deviation, I can know so much about the behavior of this event. So if I go one standard deviation to both sides, one standard deviation to the left, one standard deviation to the right, the area under that curve is around 68%. If I go one more standard deviation to the left and one more standard deviation to the right, that area will be around 95%. If I go three standard deviations both directions, that will be 99.7% of the probabilities will be within that range. So here is the question. Given the fact that flight hours takes for this company gear aircraft engines, lifetime of engine is on average 36,500. That doesn't mean that every single engine that they build will last that long. Some of them will last longer, some of them will last less. And if I know the standard deviation is 5,000, I can calculate the probability of an engine is lasting more than 40,000 using basically you can take the integral of your probability density function, which is pretty ugly. If you remember in the previous slide, if I take the integral of this function let's say fx, integral of that function fx on and between 40,000 x starts from 40,000 to all the way to infinity. Basically, I can tell you the area under this curve. I say infinity because, as you know, this tail never reaches the 0, so it never touches down to the 0 ground. Okay, so I will show you how to calculate this in Excel. Until next video, enjoy business analytics.